How you going, everyone? Welcome back to Devlog number 2 of my still nameless stealth-based QUOKKA flavoured Metroidvania.
Flavoured?
Let me know if you have any name ideas. And, if you haven't seen the premise in the first devlog, go watch that one first.
No thanks.
Not you, obviously. Basically, you'll be a QUOKKA on Rottnest Island that has to sneak their way around, avoiding the selfie-hungry humans and gaining stealth-based power-ups along the way to get into other areas of the island. In this devlog, I'll be setting up a basic camera controller, giving the detection UI a little glow up, adding a basic collectible, and slapping together some win and lose states. And finally endowing the NPC with a finite state machine so it can kind of fake intelligence. But not really. Anyway, there's a lot to cover, and I talk a lot, so let's get into it.
You do talk a lot.
Not during the logo clip, okay? Come on. Okay, first up, the camera. I wanted it to follow the QUOKKA around like it was one of its joeys. Fun fact, baby QUOKKAs are called joeys. I started by making a simple camera controller script that's suspiciously similar to the one from my last game. It basically uses the character's position and direction of movement to set a target point in front of them, then the camera chases after that target point using linear interpolation.
Wow.
This version kind of worked, but the camera's and players' movements weren't synced up, which gave it this jerky movement. So I tried Lerp's smooth cousin, Unity's smooth damp method, which seemed to be more reliable for my use case anyway. Plus, its name kinda sounds like a jazz band. Smooth damp.
Yeah.
Actually, it kinda sounds like a brand of lube.
Oh.
Here's using the Lerp method. And here's using smooth damp. Both were still a little jerky, but hey, I got the camera moving around, so that's progress. I eventually made it nice and smooth later on anyway, but for now, I picked the smooth damp method and moved on to player detection before I spiraled too much. The detection UI I had floating above the NPC had decided to take an early retirement after I added the vision cone mesh. I got that working again by slapping the old detection code into a brand new script and slapping that onto the NPC. I also made the number tick back down when the player wasn't being detected, just like real stealth, or real stealth games at least.
Innovation.
Here's what it looked like. And yes, I know it's still hard to look at with the jerky camera setup, but for now just squint and pretend it's intentional cinematic jitter. Also, that mysterious little green square, it's a collectible item. Ooh. It doesn't do anything yet, but I can tell it wants to.
It's green with envy.
Oh, good one. Anyway, the logic for that comes after this quick UI update. Now long term, I want a slick detection bar above the NPC, but in the meantime I needed a placeholder that actually told me what was going on. So I threw in a little circle sprite over the NPC, and slowed down the number ticking up. Then I wrote this bit of code, that uses the value I creatively named court time, and lerps the sprite's colour between green and red based on that value. Court time is set to 5, so as the number ticks up from 0 to 5, the circle slowly shifts from somewhat safe green to get the fuck out of there red. But when I made the game full screen, the timer seemed to tick up a lot faster. Turns out I was using update for the detection timer, which is frame rate dependent. The faster your PC, the faster your failure. Can I add dynamic difficulty to the Steam description?
No. And don't put this on Steam.
I was obviously okay, whatever. I moved the logic to the fixed update method, where it belongs. And also made the colour change in steps on each integer between 1 and 5 instead of smoothly on each float value. This is what it looked like after the patch. Kinda working, kinda janky, but kinda move on. Let's move on. And finally, I made it so the UI only shows up when the player's actually being detected, and politely disappears again once the danger passes. Unlike this devlog, which is almost guaranteed to overstay its welcome. Like and subscribe to cut it short now. No? Okay. I guess I'll keep it going. Alright, back to those items I mentioned earlier. I knew the stealth power-ups were going to be crafted out of or traded with the collectible items. Step 1, put an item object into the game. Nailed it.
Good for you.
Step 2, give the player character object an item grabber script. I'm very good at naming components. At this point, it just destroys the item on contact. And it worked. Nailed it again.
Okay, that's enough.
Now we just need to make picking it up actually mean something. So I added a level manager object to track the player's inventory, and eventually it'll handle saving too. Alongside its significant other, the game manager. They're code dependent. Codependent. Like code that's okay. Then I chucked a Text Mesh Pro object into the scene to be my very professional looking item counter UI. Every time the player touches an item, the level manager bumps the number up by 1. Here's what that looks like in game. Except there's still no reason to collect anything.
So like 80% of open world games.
That is very true. But let's fix that by adding some basic win and lose states. I updated the NPC's detection code so that if the player gets detected for too long, it dobs on them to the level manager, which then activates a game over UI panel to break the bad news. Here's what that looks like in action. I can still move around after apparently losing though. I also updated the level manager's item adding code to track how many collectibles are left in the scene. When it reaches 0, it throws up a You Win panel.
And I assume you can still...
Yep, you can still keep moving around after apparently winning. And if you're really good, you can actually lose after winning. It's barely anything for now, but it needs the rest of the game to be updated, so I'll finally move on to giving the NPC a brain via a finite state machine. Actually, before that, there were a few other things I wanted to change.
Of course.
The classic pre-task procrastination disguised as productivity. First up was the camera. I wanted it to move at different speeds depending on whether the player was moving or not. The idea was, when the player's moving, the camera zooms ahead slightly, like a dog on a leash that just smelt another dog's pee.
What?
But when the player stops, it gently pulls back. In theory, very dynamic. In practice, it felt wrong. After adjusting the numbers for a while, it did end up improving the camera's ability to actually keep up with the player, which until now it wasn't doing very well. Meanwhile, since I'd made it so the NPC can stop at the points, its vision cone was doing this snappy insta-turn thing whenever they'd start walking again. So I added a little code to smooth it out. Just a simple lerp towards the NPC's movement direction, and now the vision cone turns smoothly. Okay, enough procrastinating. Time to give the NPC some actual decision-making power.
Careful.
What? Anyway, I started by adding a temporary action to the NPC's movement script. This one's called Look Around Action. I'm very good at naming methods. And now it just prints out something to the console when the NPC stops at a point. Here it is in-game, performing its Oscar-worthy role as NPC who stops sometimes. Next, I updated the detection script so that when the NPC's detection level hits a certain threshold, it triggers an event. At level 1, the event is picked up by the NPC movement script, which just currently yells spotted into the console. There's no reaction in-game yet, but that console? Terrified. It all worked, but I quickly realised that cramming all of this into one big spaghetti script was going to be a problem. So I finally gave in and started implementing a proper finite state machine. For anyone unfamiliar, a finite state machine is a conceptual model that describes systems with a finite number of states and transitions to represent their behaviour and logic. Basically, it handles switching between all the different states that the NPC can be in, like patrolling, idling, looking around, etc. I made a finite state machine script and added it as a component to the NPC object.
Careful, as soon as you give them free will, they'll try to leave.
What? Anyway, it's got an iState interface that basically defines whatever mode the NPC's brain is currently in. Right now, the state machine just knows how to swap between states and update them every frame in physics tick. I moved all the movement logic into a new script called Patrol State, which is basically the NPC's default walking around behaviour. The patrolling state is a type of iState and has sub-states for speeding up, cruising along, and slowing down. I gave the NPC movement script a reference to the state machine and told it to start it in patrol mode. Nothing was actually making it leave the patrol state yet, but hey, the walking part worked and it didn't immediately catch fire, so I'm calling that a win. I just want to quickly change these if statements into switch cases. Okay, there we go. Let's run it again just to make sure that didn't change anything for some reason. What? Come back!
Told you.
What does that say about me? I just moved where the stopping distance calculation was done, and it's back to how it was before. Time to test it at different acceleration and deceleration values, because testing is good. Okay, I didn't actually stop at that point. That's gonna be a problem, and I game overed. Gamed over? I lost. I'll just get rid of the HUD and bump up the acceleration a bit. It still doesn't quite make it there. Okay, I'll give it a bit of help. Ah, there we go, little buddy. Come back. I'll try it again with low acceleration and deceleration. Oh, okay. Bye then, I guess. I don't even want you here anyway. I do actually, so I updated the patrol state to include a stopped substate that kicks in when the NPC gets close to their target. This just ensures that the NPC fully stops before moving on to its next point. Now, even though they start moving straight away, they still fully stop and then start moving in the right direction. Then I updated the follow point system so each point has a type. That tells the NPC what to do there, like whether to keep their momentum, slow down on arrival, or to stop completely and wait for a bit. Since it's an enum, I get this cool drop down menu in the editor, which means slightly less typing and slightly more organisation. You can see I was already planning ahead, with a point type for stop and look around suspiciously. I also swapped the patrol state substates from strings to an enum as well, which should clean the code up a bit. The patrol state switches to the idle state when arriving at waypoints. At this point it just stands there until a wait timer counts down and switches it back to the patrol state. Let's run it and see how it goes.
This'll be good.
It can now stop at this point for a few seconds before moving on. This next one is a continue point, so... okay, oh, not this again. After a little code cleanup and turning the acceleration back up again, I made this simple path. 2 stop points, a wait point set to 2 seconds, and 2 continue points. It's nothing fancy, but it's a solid foundation, I hope. I eventually add more actions like the stopping and looking around at certain points, or stopping and menacingly facing the player when they spot them. And I'll have to add a whole bunch more once the rest of the gameplay is more updated. But that's enough for this video, I think.
Aww.
Yeah, I know. In the next one, I'll make a colour palette, draw some character art, implement sort ordering so the QUOKKA can either be behind or in front of certain tiles, and a few other small updates. So stick around and follow along for more devlogs like this. See ya folks, have a good one.